Hi guys, welcome back to yet another live session with Newton School. Today we are going live with two very interesting people, and it's going to be a time for all of you to learn. I know that a lot of people here are interested in getting into Amazon, Microsoft, Flipkart, and a lot of big organizations. But the catch is to crack the interviews. So today we are showing you a live mock interview where you are going to learn a lot of things about interviews at all these organizations. So without much further ado, let's invite Parmesh Ashwath and Saurav Tiwari to this call. Parmesh here works with Amazon and is very good at Java, MongoDB, and a lot of other tech skills. He has a lot of knowledge in the field, and he'll be interviewing Saurav Tiwari today with Newton School. So we'll invite both our interview panelists to this call, and I'll share the baton to you guys. I don't want to waste a lot of time from you. You guys can take over.
Yeah. You are talking on mute, Ramesh.
Oh, sorry. Yeah, thanks.
Mhm.
Thanks, Gopi, for the intro, and let's get started, Saurav. So basically, in the next 50 to 55 minutes, we will have a mock DSA interview, and in this interview, basically, we will be going over some of the concepts of DSA and then some of the problem-solving skills in the DSA. So let's get started. So let me give a brief intro about myself before getting started. So like Gopi introduced, my name is Parmesh and I work in Amazon as a SD2. And I work on a tech stack of Java for the backend and front end Angular and React as well. Prior to Amazon, I was working with Cisco for the past 5 years there as I was working as a full stack developer, and the tech stack is almost the same. So yeah, that's about me. Can you give a brief intro about yourself, Saurav?
Uh, yeah, Ramesh. So recently I graduated from my BTech, and last year from January I started a internship in NCR Corporation, and now I'm currently working in 7-Eleven as a software developer. And talking about my skills, so I am very much comfortable in MERN stack, and I used to I write programs in Java language, and I have worked on machine learning also. Yeah.
That's great. Okay, so here is what we will do. So we'll begin our interview with some of the basics of data structures, and then let's get into the problem solving area. Is that fine?
Yeah, sure.
Okay. That's great. So to begin with, Saurav, can you tell me what is the difference between the insertion sort and the selection sort?
Okay. So insertion sort and selection sort are major differences you can say. In insertion sort, we start from we suppose we have an array, and we want to sort that array. So in insertion sort, what do we do? So we will create first we will start from a starting position, and we will create a sorted and unsorted array. So and we will put each element from one sorted array to sorted array and on its correct position. Suppose we have 5 4 3 2 1. So I have 5, and then 5 is sorted array and 4 3 2 1 is unsorted array. Then I will pick a 4. So 4 I will put it in on its correct position, which is then 4 and 5, and so on. I will do that. And in selection sort, what we will do, we will pick a minimum element from the unsorted array, and then we will put in the first place of the array. So we will do in that. So and in selection sort, always there is a time complexity of n square, but in insertion sort, the selection in insertion sort, the best time complexity is O of n, and worst is O n square.
Okay. So you mentioned the time complexity of O of n to be the best scenario. So can you tell me in what is that scenario that will lead to O of n?
So best scenario of insertion sort is when the array is already sorted. So it will give us the OFN.
Okay. So can you tell me which one is the stable sorting and which one is the unstable sorting?
Okay, so stable, our insertion sort is stable,
Mhm.
and as compared to selection sort, it's also stable because there are only n swaps only. So if suppose uh, we have like system which is like very like there is a write memory write is very costly. So
Mhm.
so for that selection sort will be like better approach because in worst case you will only swap only n elements, nothing more than that.
Okay, got it. Okay, so moving on to some of the searching techniques. So can you tell me what do you understand by a binary search and what is the scenario that we'll be using the binary search for?
Okay, so binary search is like work on like divide and conquer method. So in which way what we will do, we will divide the scenario problem in a sub problems. So in two sub problems, like there is like you can say uh, so we divide into sub problems, and our answer will lie on the only one in one sub problem. So because of that, what will happen is our half you can say working field like it vanished. Like we have to only work on a half we have to only work on half field, not on full. So it always reduce our working space. And also the time complexity is very less. It's only log n in binary search. Yeah, but for binary search, the arrays should be sorted.
Okay, okay, got it. So can you explain the stack data structure and mention some of its applications?
Okay, so stack works on our LIFO, which is last in first out. So in this, like we the you can say stacks application is like widely used. Like suppose you want to convert a infix to postfix or prefix to postfix. So for this conversion, we use generally stack. And moreover, so stack is also used in recursion call. Whenever we use recursion, so there is a inbuilt stack. So and even suppose we have like we want to store something, uh, it's like a backtracking thing. So we can use stack there.
Okay. So you mentioned the stacks are used for LeFo, last in, first out. So if I have to use, is it possible to use stack for the first in, first out, or is there any other data structure altogether that I can use?
Not directly, like you can not directly use stack last for first in first out. So for first in first out, like so for first in first out, it's like there is a another data structure which is queue. So we have to use that for that.
Okay. Okay. So can you tell me how are arrays different from linked lists?
Okay, so array is like our continuous memory block, and linked list is like uh, it's not continuous. It's dynamic. So what's like array, like linked list provides us now. Linked list provides us very, you can say, a memory utilization. Like suppose we don't have enough space for, like we don't have a continuous space, so we can, like in linked list we can provide still, but in array we can't provide. And also like in linked list, insertion and deletion operation is very easy as compared to array. But in array we, there's a what you can say, uh, the best part of array is like it provides a direct access method of the element. For linked list you have to iterate over the whole linked list, but for array you have direct access.
Okay. So you mentioned about the insertion and deletion, right? So can you tell the time complexity of each data structure?
Okay. So suppose for you want to insert element in array. So you have to shift places, like if you want to insert a insert a element in array in between, so you have to uh, shift the rest of the element. So it can take order of n, and but in as you can say in a linked list, it is very easy because you just have to like break the pointers and you have to create a new pointer there. And for deletion also, you can say it will be there if we don't use any other method. And and apart from that, uh, yeah, so but yeah, in linked list there is a, you can say, uh, disadvantage of linked list, that it contain it like there is a, you have to store the reference, so it contains extra, it takes extra memory.
Okay, got it. Yeah, that's great, Saurav. So let's move on to the next section of problem solving. So
Okay.
what I'll do is I'll share a link with you, and you can open that link and also start sharing your screen. Let me put the link in the chat. Yep.
Okay. uh, I have no question. Is it visible now?
Yep. Okay. Yeah.
Okay.
Okay. So here is the problem. So what I'll do is first let me paste the question in the edit window, and then let's go over the details of that question.
Okay.
Okay. So basically the question here is, Saurav, you have given a board with m cross n cells. So you are given a board with which is of dimension m cross n, and each cell within that board represents the state of life,
Hmm.
whether it's a living state or a dead state, represented by 1 or 0 accordingly. And each cell interacts with its neighbors, and you need to consider the 8 neighbors, possible neighbors, horizontally, vertically, and diagonally. And there are certain rules that are given to you. You need to apply those rules and come up with the next iteration of that board. So when I say next iteration, whether a cell will be alive or dead in the next iteration. So that's the question. And you need to remember that you need to apply these rules simultaneously. So it's not like you will apply a rule and then for a one particular cell, and then for the next cell, you need to take its previous state and not the updated state. So you need to apply all these rules simultaneously and come up with the next iteration of that board. So this is the question. Go over the question and let me know if you have any queries on this questions, and then let's get started with your approach.
Okay. Sure. Okay. So the input will be a 2D array.
Correct. A 2D array whose dimensions are also specified to you by m and n.
Okay. And okay. So is there any limitation for any extra space? Like, can we use extra space?
To begin with, I'm okay if you use an additional space. So let's go over the optimization, if possible, later. To begin with, if you come up with an approach where you are using an additional space, that should be fine.
Okay. Okay. So so I have to only write a function for that.
Correct. You can assume that the input is given. If needed, I can paste a sample input and output also for your reference. So just a second. Okay, so here we go. Uh, So this is the input array. You can assume that the input array is given to you, and the expectation is that the output is displayed in the manner that it's shown. And you can see that all the rules that are being specified are applied to the input to arrive at the output.
Okay. Okay. So currently, like the brute force approach, like I can think about a brute force approach.
Mhm.
So brute force approach will be like simple. As we have a 2D array, so the lower limit, obviously it will be the time complexity of lower limit should be m into n.
Okay.
Yeah, we can't do in linear time complexity. Yeah. So okay. So the brute force approach can be like we if we use extra space, like we can create a extra 2D array,
Mhm.
which is initially all the elements in the that extra 2D array is zero, and we just see like we will iterate over this input array and see like current element is my zero. Okay, and
Okay.
we will see the neighbors of this. Like first of all we will see the neighbors and we will count if the count of live cells
Mhm.
is it's like if the count of live cell is less than 2, then that means I have to put I have to put a zero in the second array, in the like in the extra array. And if the live count is 2 or 3, that means we have to put a 1 in that.
Okay.
And if it is more than 3, then I have to put again a 0.
Okay.
And if the count is, and if the dead cell, like suppose there is a dead cell of 0
Mhm.
and it has a neighbors of 3 live cells, exactly 3 live cells, so I will put a 1 in the extra array.
Okay. Why do you need an extra array? Why can't you just update the input array?
Yeah. Yeah, so that was a brute force approach. Yeah.
I mean, even let's say during the brute force approach,
Hmm.
you what is it that we will lose if we update the input array directly?
So basically, if we update the input directly, so it is not simultaneously like, I mean, it's not like if I update the 0, I
Mhm.
mean, if it has a live cells, two neighbor live cells. So if I will update this to 1, then what will happen? Then it will be, confusing for others to identify that, like, is it a live cells now or is it was before? Because
Got
it doesn't depends on this scenario. It's always like taking the input as a whole. You have to change
it.
the simultaneously.
Okay, yeah, that's correct. So what we can do is let's get started with the code for this with for the brute force approach, and see how to go about the additional space a bit later.
Okay, sure. So it's like live cell, and it is taking the input of and we have what is a board. Okay, so it's a board. Okay, so currently I have created this function. Uh, okay, so first of all, we need a length of this board.
Mhm.
So it will be board dot length, and then we need number of columns also, which will be board 0. So we have this now. We also need a extra array, so we can take extra. Okay, so extra array will be of same n and m, and extra array done. So now we have to just iterate over the uh, why it's a double lines. Okay, so j equals to 0 to j less than m, j plus plus, and now we have to iterate over each element of board. So I will like I have to okay. So first, like suppose we have this zeroth element, this elements.
Mhm.
So it can have maximum of 8 neighbors.
Correct.
So and the corner like yeah. So I have to take care of corner cases also. Okay. So for that I have to create a. It will be better if I will create a separate neighbor array
Okay.
like and neighbors. Okay, so uh okay, if that can be possible,
So neighbors is also a two-dimensional array, is that?
yeah, yes, like it will contain only 8 elements. I mean, I'm not I'm just adding like suppose you have 0 comma 0.
Okay.
Okay, so its neighbor will be the 1 comma 0,
Mm-hmm.
and then here it will be minus 1 comma 0. No, sorry. It will be 0 comma 1, and it will be 0 comma minus 1, and above it will be like 1 comma 0,
Okay.
and so we can create the 8 neighbors. So it's just a position. It's just a position for 0 0,
Got it.
but it will hold true for every position. Like we just have to add.
Got it. Go ahead. Sorry.
So I'm just like creating a 8 neighbors position. Okay, so it will, if I will start from minus 1 and 0 and minus 1 comma 1. Okay, next can be 0 comma minus 1, and 0 comma 0 will be the current element. uh, then I have to see 0 comma 1, then next will be 1 comma minus 1, 1 comma 0,
Mm-hmm.
and last will be 1 comma 1. So I guess we have 8 elements now. A, 1, 2, 3, 5, 6, 7, 8. Yeah. So I have 7 neighbors position, which I will use. Yeah.
Okay.
So what I will do, I will take a live count, live cell count. So live count, I will initialize as 0, and I will update. I will check so I will check. So how many live cells this element has in his neighbors.
Okay.
I will check this. So for that I need a for loop to iterate. Uh, each neighbor will iterate, and, and so this will be like it will take each element as a single array,
Okay.
1D array. So then I can do, so I will denote the position of neighbor as x and y. So x will be my I plus this neighbor, and it will be on 0th position. And same for y also. And but it will for j.
Okay.
Okay. So now I have x and y, and what I have to do now. Now I will check if x should be in the range. So x should not go beyond the range. So x should be greater than equals to 0,
Okay.
and then x should be less than n,
Fine.
and y should be greater than equals to 0, and then x and y should be less than m. And then
Okay.
okay, so now what we will do, uh, so this will check the condition if my neighbor is valid neighbor or not. And now I will check if my board my neighbor x, which is the position xy, equals to 1 or not. If it is, if it is equals to 1, then what I will do, I will do the live count plus plus. So this will what this loop what it will does, it will just check the neighbor, my all 8 neighbors have live count, how many live count he has, like how many live cells he has
Okay.
as a neighbor. So it will be helpful. And yeah, this for loop is like and here. And when I will have the live count, then I will check if live count, if live count, now I have to check the conditions. Okay, first I have to check that my board,
Mm-hmm.
my current element I comma j, my current element is 1 or not, like is it dead or alive. According to that I will check, because there is a condition according. So if it is 1, that means it's a live cells. So for live cell we have 3 conditions. First condition is that if the live count is fewer than 2, so it will die. Okay. So if my live count is less than 2, that it means then it means it will die. So I will update my extra array as as 0 because it will die. So it will be 0. And now, else if life count is not less than 0, if life count is if life count is 2 or 3, so it will yeah, it will be 1. And if more than 3, then it will die. Okay. So if life count is equals to 2 or equals to 3, so it will survive. So I have to update my extra array as 1.
Okay.
And third condition is, and else my third condition will be it will die because of overpopulation. So
Mhm.
my extra array, okay, extra array I comma j. So my extra array should be 0. Yeah, so my extra array will be updated for if lives if my current element is 1, and if it is not 1, so else it will be 0 obviously. So what I will do, so for 0 it is only there is only one condition. If it is 3, exactly 3, then it will become 1. So I will check my life count. If my life count is, so I will check if my life count is equals to 3 or not. If it is, then I have to update my extra array as 1. Else we will leave it as it is. So now my extra array will contain this output.
Okay, got it. So looking at the code, so can you scroll down a bit?
Okay.
So what? Yeah, it works perfectly for the given conditions. You have handled it explicitly, and it works perfectly. So is there a way that we can do some cleanup on the if-else conditions? Currently, I'm seeing too many if-else conditions in the code.
Okay. Uh, we can do, so what I can do if else live bound is less. For that I can add in else if live count is, this can be clean. I guess it is not required. This if it is not required because, and this will is not required. So there is only one condition. If live count, then I will update as a 1. Otherwise, yeah. What I can do, even I can short this further.
Yeah,
Uh, so then it will update. Yeah. Else then for the same I can do that. Else if now I have to add a condition here. Else if it is 0 and then live count is equals to 3. So then it will become, yeah, yes, good. Oh, then it will become this. Yeah.
Yeah, this is good. There is a minor issue in your first if condition. Can you identify?
Yeah. Hello.
Yes, sort of. Yeah, this is good. So what I was saying was there is a minor issue in the if condition that is put up in line number 49.
49.
It's
There
just
is there's a issue of what?
yeah, your code might not work for all the cases if I execute it. There is a minor issue in the line number 49 if condition.
Okay. For else it will not do anything. Else if it is 0. Parenthesis, I think it will be
Yeah,
okay.
exactly. It's the order of execution, right? First you need to
Yeah.
make. Okay, perfect. So this is really good. So it what is like I think you mentioned it before. You can you tell the space complexity and time complexity of this again, Saurabh?
So time complexity will be order of m into n into m, and it will take extra space of the same. So it will take extra space of n into m also.
Okay,
Yeah, because it is a constant space. This is a very constant space, so it will not be considered. So this is only the extra space I am using.
okay,
This extra array.
okay, got it. So is there a way that we can achieve or solve this problem without using an additional space?
Yeah, yes, we can. For that, what we have to do, we can. Okay, we have to update also. Uh, we can do one thing. Uh, Suppose like a live cell is like we have to change a current cell, current element. We have to change a current element to 0 to 1. So what I can do, when I want to change it to from 0 to 1, uh,
Okay,
like suppose I want to change it to 0 to 1. So I will represent it as a 2 in the matrix.
okay,
And when I want to change to 1 in any current cell, 1 from 0, so I will represent it as a -1,
okay, fine.
so that I can like I will be sure. Then I can like again go through on the board, and I will again like I will get to know that okay, this is now currently 0 and this is now currently 1.
But doesn't your update be impacted because you're changing the values to -1 and 2? Will you how will you handle that?
Okay, so we have to use extra, extra loops for that. I mean, after doing these all things, we
Mhm.
have to just run a two loops again.
Okay,
Like if there is a 2, then I will change it to 1, and if there is a -1, then I will change it to 0.
okay, okay. So let's see how it comes up in the code.
Okay, sure. So now in this, what I can do, we don't need extra array, so I can remove. I need this still. I need neighbors, and I can do one thing. This is fine. Till here it is fine. Yeah, not fine. Okay. Now I have to do one thing. Uh, so now, as I told you, that now my board can contain -1, 1, 0, and 2.
Yeah.
So my board can contain now 4 elements. So it will like if it will be a -1, that will signify that previously it was 1, now it is 0.
Mm-hmm.
So I will take, so in this my execution, this in this, if I will consider -1 as a 1. So let's suppose if my board xy equals to -1 also, then it will be also satisfy the condition.
Okay, fine.
For 2 I have told, I haven't, yeah, I will not do anything for 2. Life count is plus plus, then yeah. So if life count 2, life count 3, I know now I have to change in. Okay. So for this I need board ij should be changed. Board ij should be changed. If board ij equals to 1 and life count equals to 2 and life count equals to 3. Yeah, so I don't have to do anything. Then I have to just, I don't have to do anything because it is already 1. Yeah, so I don't have to do. I have to change when my cells change to -1 to 1 to 0 or 0 to 1. So if life cell is with fewer than 2 live numbers, okay, with fewer than 2. So currently the condition is for. So I have to change for fewer than and for overpopulation. Okay, less than 2, or if it is greater than 3, greater than no, greater than 3, I guess. More than 3, yeah. So greater than 3.
Okay.
Then I have to update my board ij. Uh, then my 1 will become -1. So it will represent that, what it will represent, that previously it was 1, now
Mhm.
it is become 0. So I will represent it as a -1.
Okay.
And in my second, if my board ij equals to 0 and life count equal, now for this I have a condition, if there is a 3, exact 3, so I don't need extra array. uh, if it is exact 3, then I have to update it as a 2.
Okay.
It will signify that previously it was 0, now it is become 1.
Yeah.
Yes, now again what I have to do, I have to run a loop again for this. So jm j plus plus. And now what I will do, if my board ij equals to -1,
Mm-hmm.
that means it is 0.
Okay.
So I will update it as a 0 in my, and I'll say if it is 2, then I will update it as a 1 in my board. Yeah, then yeah.
Okay, yeah, that's that works perfectly fine. Okay, I think I have one more follow-up question on this, Saru. So let's say you don't have to write a code for this part of the question, so you just have to tell me the approach that you will be taking, and that should be fine. So the follow-up is now, let's say
Okay.
I have an infinitely large bold for you. So where the way that we are iterating is might not be possible because of the memory constraints of the system. So
Mhm.
how do you handle that scenario? Will there be any change in your algorithm, or will there be any change in your data structure that you are using? What is that approach that you will be taking in for an infinitely large board?
Okay. So for if I will have infinitely large board, okay.
And remember that you can also take that it's given, or it can be assumed that it's a sparse matrix where the number of leading
Okay.
cells are very few.
Okay. 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 So if I have infinite board, so and if it is a sparse matrix, so then it will be like there will be a very less live cells.
Correct.
So then we don't have to iterate over whole board. We
Hmm.
just have to iterate over the live cells.
Okay.
So because we like it will be waste of time if we'll check again and again for each and every element of the board if it is infinite. So I will do, uh, I will see, I will check the location of the live cells, and for the live, only for the location of live cells, I will I will do all these things which I done this in this.
Okay. So instead of a two-dimensional array, what is it that you will be using it?
Okay, so instead of two-dimensional array, we can use, because the two-dimensional array has some limitation of memory. We can use a simple uh, okay, hash. Yeah, we can use hash map.
Okay.
Yeah.
So what will your hash map be containing?
So hash map will like hash map will have the location of the live cells, and so then if it can be like it will be easy for us to just just iterate over only the live cells, the only the that location of live cells. We don't have to go over the dead cells.
So what you're saying is you will just be storing x comma y,
Yeah, location of live cells.
location of the cell.
Yeah.
Okay. So again, you don't have to write the code for this. Can you just give a very high level pseudo code? How will you handle the updation of the state, given that we are now representing it with just the position?
Okay.
Very high level pseudo code.
So first, uh, code can pseudocode can be like, suppose we have the 2D array of this right. So like I have a board,
Mhm.
not a, no. So like I have an infinite board currently. So what I will do, I will just iterate over this, and I have a hash map which will store the value of just, you can say, which will store the value of this x and y, the location of the live cell. I will check if it is a live cell or not. Then if it is, then I will store in our what can I say, map. So if a board,
Yeah, this part I'm not able to get. Like, what exactly will your hash map? Hash map is a key value, right?
yeah.
So what will be your key and what will be your value? Yes, you need to use a kind of a map data structure, but what will be your key value in this scenario?
Okay, so key can be my location, I can store the location as X and has some space. So it will be an integer
Mm-hmm.
or it will be a string.
Okay.
And so this will be a key. The location will be the key, this key. And integer can be the updated value if it is a 0 or 1.
The updated value.
Yeah.
Okay, got it. Having key as X space Y. Uh,
Yeah,
will,
X space Y.
okay,
Like this type. This thing.
sure. Okay, so yeah, this works, and then you will iterate over the board and apply a logic to check out all its neighbors to determine the new state. Okay,
Yeah.
that's good. Okay, I think I have covered all my questions, Saro. So let me know if you have any questions for me. I would be happy to answer them.
Okay. So I just want to know that so though this infinite we have an finite board. So is there any approach apart from this, like to solve this question?
Yeah, so basically, one thing that we need to consider is the memory constraint for the given board. So for a given board, you mentioned that we will iterate and construct the hash map. So the whole problem here was will not be able to iterate the board to construct. So the assumption that we made is we know the positions of the leaving cells beforehand,
Okay.
and that is something that was mentioned in the question while explaining. So that is something that is given to us where we are given an hash map with uh, not an hash map exactly. We can call it as a counter, because we will need to know the number of occurrences of the leaving neighbors. It's not just whether the leaving cell or not cell, if we are interested in that metric. So that is something that is the first thing that we need to take care. The second thing is, even let's say it's something we will not be able to operate on the given board. Let's say we will have to, it's just that the board that is given to us and not the we need to construct the hash map. So
Yeah.
now the question comes is, how do I construct the hash map? So for that, we know that the neighbors will live in the three rows, right? It's just
Mm.
that let's assume that it's in the file system or it's in our database somewhere. The board complete is in database. It's not able to fit in our memory due to the memory constraints. So
Yeah.
now all I have to do is to load just the three rows to construct the new state of the board in the next iteration. So it's not the complete matrix that I need. It's just that the three rows that I need. So this is another way of thinking. So
Okay.
this is how you will have to kind of approach this question.
Yeah. Yeah. Good.
Okay, yeah, that's really good. Saurav. So I think any other questions from you?
No.
Okay, that's great. Okay, Gopi, how do you want to take this to the next?
This was great. I was constantly watching it, and I feel, Parmesh, could you just give us give sort of an idea as to how you thought his interview was?
Sure, sure. So firstly, yeah, it was really a good performance in the interview. So basically, it started with this is kind of a typical interview process for an SDE, where it starts off, if it's a DSA round, it starts off with some of the basics, and some interviews will directly jump into the problem solving, but some will try to see what is your strength on the DSA concepts and then move on to the problem solving section. So I think Sauro did really good when it came to the basic concepts. There was a couple of things that were missed out in minor details from the selection sort, insertion sort, but apart from that, I think all the answers were answered perfectly. So what I would suggest, Sauro, is when it comes to the differentiating aspect of the algorithms, try to spend more time and try to see what is the best scenario to use a particular thing, and try to first explain the algorithm and then give a real world example if possible to it. So and then what are the scenarios which in which one algorithm stands out when compared to the other algorithm. So these are the minor details. If you add in, it gives much more better impression to the interviewer. So and then when it came to the programming, I think you took a right approach of first understanding the question in detail and then getting into the coding aspect. A few very minor details is I think you directly jumped into the programming language of choice to be Java. So if I mean, it's okay for a fresher to directly jump in and get in there, but it would be much more better if you can ask the interviewer what is the programming language that I can choose, and then get in there. And then when coding, I think you did a right thing of keeping the interviewer always engaged, speaking out your thoughts, what exactly is running in your mind. That way, I think it went really good. You can work a bit more when it comes to the variable naming aspect, where you did a good job there, but in some variables, I think you can give a better name so that it kind of becomes a production ready code. And then when I asked you to revamp your code to optimize or better give a better coding style in terms of if else condition, you again did a very good job there. So, and coming to the follow-up questions, yes, I think when it comes to the design aspect of it, I think you can spend a bit more time in terms of what are the different criteria that you need to consider when it comes to the scalability, when it comes to the time complexity, and then approach the problem in those terms, in terms of scalability and complexity, mostly in terms of the follow-up questions and the design related questions. So apart from that, I think the interview went really good. Good job.
Yeah, thanks.
So we'll just take one question from our audience. There were a lot of discussions going on in the live chat as well. One of the questions that we've got is, Rohit Pal wants to know, should we start to code the brute force approach, or first should we optimize and then code? Parmesh, would you like to answer that?
Yeah, I think given the time constraint, what I would suggest is tell the brute force approach to the interviewer first, and then because you need to start from the basics. So first explain. You need to make sure that you have understood the problem right. So to do that, start off with the brute force, and you don't have to always code the brute force approach. This problem was kind of a bit a tricky one, where handling the boundary conditions and how exactly we'll handle the state change. That's why I asked the candidate to code the brute force approach. If not for a kind of a simple array manipulation, tree manipulation question, you don't have to actually code the brute force approach. But it's always better if you start with the basics, explain the brute force approach, and ask the interviewer whether you have to code for it. If they ask it, it's just a matter of converting whatever you have explained in terms of code. So do that and then get into the optimization aspect. But yes, you need to keep yourself big chunk of time for optimizing, because brute force approach is not which you will be evaluated against. So spend a minimal time in explaining the approach, and if asked for code, write the code, and then spend major time in optimizing the algorithm.
Right. So I'll quickly ask one question to each of you. Saurav, we'll start with you. When you were preparing for this interview, and when you are preparing for interviews, what is your mindset like? And what is the kind of practice that you take up to make sure that you're performing the best?
Uh, yeah. So like whenever I prepare for an interview or something, like first, like if it is a DSA or something, so I just don't first I don't like first I always think that I should be go with a positive mindset, and whatever will like if an interviewer asks, I just have to positively like think, and then I have to give the answer. And there there's a nothing much you can say hard and fast rule for that. Like as Pramesh said that like you should start from basic and so I always try for that. Whatever I know, so I should start with that. Even if I know bit of any question, so I always start with that. And always the interviewer always gives a hint like what should go forward, so I always try for that in an interview.
Right. Thanks, Saurabh. So my next question is for you, Parmesh, and that is, whenever a candidate is trying to, reach out to bigger organizations and is trying to apply to all these big organizations like I named previously, and Amazon as well, what do they essentially have to prepare? How long should they be preparing for? So can you just give us a brief about how a preparation for an actual interview should look like?
Sure, Gopi. So basically, for the preparation, right? I think again, it depends upon an individual how much time they will spend per day and the length of the duration for the interview itself. But in a whole, I think if you need to kind of start with the basics. Like for example, you need to start with understanding what the algorithm does in detail, and then what are the different data structures that are available at hand. Once, if you are kind of comfortable with that, and then what I will always suggest is next take up as a next step, you need to go with the different approaches that are available for you to solve. Like for example, if it's an array or a string kind of problems, what are the different approaches that are available for me? For example, if I have to name few, two-pointer approach, and the merging sort algorithm kind of an approach, where and the sliding window, these are the different kind of a standard techniques that are available to solve any kind of a given DSA. So first step is learn about all the algorithms and the data structures that are available. This next step is go algorithmic wise or an approach wise. Take a two-pointer approach, solve like almost all the different flavors questions that are possible in that, like 5 to 10 questions, and then next go to the second approach that is available. That way what happens is, during an interview, if you are given a question that you haven't seen before, because it's very possible that you are given a question that you haven't seen before, and that's when the student kind of gets panicked. But at least if you are kind of able to land with an approach that needs to be applied to a problem, that means you're kind of 60% through the interview. So identifying an approach means that you need to be comfortable with that approach, in what are the different scenarios that can be applied. And then comes the practice part, where you need to kind of just practice. And also what I always suggest is follow a Fibonacci series while practicing. So you solve a problem today, and then again after 3 days resolve that problem, and then after 5 days you solve the problem again until you are way too comfortable with that problem. So that you don't have, because it's kind of a common issue with everyone, including me, that we will just forget the approach that we haven't used for quite a bit of time. So that way it becomes much more easier. All the approaches are in your mind, and then you just go to the interview and you face the interview and with a positive mindset, like Sarah mentioned.
Okay, awesome. I'm really grateful that you guys joined me on a Sunday evening. Thank you so much, and I hope that you guys have a good week tomorrow.
Yeah. Yeah. Thanks, God.